Okay, camera, I got it right. So this is the first one, 4.1, right? Now this we just start off with this, see how it goes, right? So it says find the slope of the tangent to the curve at the given point. So the curve is y is equal to x squared minus 3x plus 2. And that's it plotted there, okay? I just plotted it real quick, right? Now, at 0.10, so at this point here, x is 1, so we go x, this is the x-axis here, right? And then that's the y, right? So we go 1 out, right? And the y value is 0, so that means that it's cutting the x-axis. Anytime you see y is 0, it's cutting, and x just goes along here. So they want to know what the slope of this tangent is at this point. Now, that's the tangent, right? So basically, a tangent is the slope of this curve at that point. That's also what tangent means. And that also means the rate of change of y with respect to x, okay? Because, you know, if x is a big number and y is a small number, you know, you have it's a steep curve, etc., etc. So dy dx, or the rate of dy dx, is also the rate of change of x with respect to y, which is also a tangent, which is also the slope of the tangent, which is also the slope of the curve at this point. So you got to know how to translate all those terms into one common concept, because that will confuse you, right? So dy dx is the rate of change of the slope. Basically, it's the slope at this point given a tangent. So you know, if you draw a tangent there, so it's steep. So like if it was at the very bottom and you draw a tangent, that's flat, right? So it's not doing anything at all. So that's what it is the rate of change. Now, so the slope is also the rate of change of y with respect to x, which is dy dx, which is differentiation, right? Now, I presume you've done that, right? And we can go over that if you're not too clear on that, right? Let's wait this. Okay, so yeah, this is a bit blurred, all right. So we got y is equal to x squared minus 3x plus 2. Okay, there we go, yeah. dy dx is equal to 2x minus 3, all right? So I had to differentiate this, all right? So the way you differentiate, let's say x squared, you bring the power, you put it in front of that, and multiply by whatever is there. In this case, it's 1, right? So you don't see that. So it's 2 by 1, and then you take 1 from the power, so you will get 2x, right? Because 2 minus 1 is 1, so you get 2x to the power of 1, right? Which is x, right? And then minus 3x, and the differentiation of minus 3x is 3. The differentiation of a number is always 0, so that goes, right? So again, if you want to differentiate x squared, you bring the 2 down, x to the 2 minus 1, you get 2x, and x to the power of 2 minus 1 is 1, so x to the power of 1 is x, okay? In this case, you got 3x to the power of 1. You bring the 1 down, right? So it's 3 by 1 by x, and the power is 1 minus 1, which is 0, and anything to the power of 0 is 1, so it's 3 by 1, okay? So that's how you get that, right? So that's the rate of change of this curve at any point of x. So let's say that's a formula. So any point. Now what we want is when x is 1 and y is 0. Okay, so you get x is 1. Well, there's no y value in this, so we just have to put in the x value. So dy dx, which is the rate of change of the slope, or the slope, at that point is 2 by 1, where x is 1, right? X is 1 and minus 3. So you get 2. So 2 by 1 is 2. Minus 3 is equal to 2 minus 3, which is equal to minus 1. So the slope of the tangent to the curve, to the curve at the given point, is minus 1. So any slope that you see going this way is always negative, and anything that way is positive. So you know you've got the right answer, right? If it's flat, then it's 0. Okay, so that's minus 1. It's always negative this way and always positive that way. Okay, so you've learned a few things there. Okay, so I'll come back and get another one. We'll keep going. See how that goes. Try that on your own and then look at this. Okay.